Number 25, draw the graph of y equals square root of x minus 1. What I did was I had put this into my calculator and I had went to the table and plotted these points. Notice how I have whole numbers here at 4 because 4 is a perfect square. And if I had scrolled down to 9, 9 is a perfect square. So square root of 9 is 3. 3 minus 1 is 2. So this is how you get these points. So I'm just going to plot the points 0, negative 1, 1, 0, 4, 1, and 9, 2. 0, negative 1, 1, 0, 4, 1, and 9, 2. This graph starts at the y-axis. I cannot plug in any negative x values. Goes all the way to here. You will lose a point if you do not have an arrow because this graph does continue on forever. In number 28, they ask you the vertex of this parabola has the coordinates 2, negative 1. If I put this equation into my calculator, this is what I have. I go to my table, and here is my graph. If I plotted all the points, this is the parabola I have. Now notice it says the use of the axes below is optional. Now this means that this is a graphical transformation. Now because the x minus 2 is in parentheses and because this is a minus, this means I'm going to the right 2 units. So if you wanted to, and if you plugged in f of x minus 2 into this function, you would have x minus 2 squared minus 4 times x minus 2 plus 3. There are different ways to look at this problem. So if I plug this graph into my calculator and then go to table, I'm going to plot these points. Notice how this graph, notice how the new graph has shifted over to the right 2 units. The directions say to state, find the coordinates of the vertex of the new parabola. The vertex is 4, negative 1. 4, negative 1. It says explain how you arrived at your answer. You could say anything along the lines of you substituted x minus 2 and then you used your calculator. You could say that you knew that this was a transformation of going over to the right 2 units. On the set of axes below, draw the graph of the equation y equals negative 3/4 x plus 3. To do that, you can plug this equation into your calculator and then go to your table of values and then plot the points if you'd like. What I'm going to choose to do is I am going to start at the y-intercept of 3 on the y-axis, and then my slope is negative 3/4, so this means that I'm going down 3 and then to the right 4. Remember, when graphing lines, we're always moving to the right. The negative means down, so I'm going 1, 2, 3, 1, 2, 3, 4. If I connect those 2 points, this is the line I get. Now remember, these arrows in this case are imperative because this line does go on forever. Now they're asking you, is the point 3,2 a solution to the equation? So the point 3,2 is right here. Now notice how it says, explain your answer based on the graph. Because 3,2 does not lie on the line, it is not a solution. So based on this graph, I could say 3,2 is not a solution because it does not lie on the line. That would give you full credit. The function f has this domain and the range. Could f be represented by the following? Well, notice how 1 is being used from the domain, 3 is being used from the domain, 5, and 7. It's paired up with the elements 2, 4, and 6 from the range. Could this work? Yes, because all x values correspond to exactly one y value. Remember, if there are repeated x values, it is not a function. It's okay to have repeated y values.